TSWREIS Nakrekal Girls, Nalgonda District. How are you girls? Children, can you tell me what is my position? I am in standing position and I am at rest. Now I am moving, means that I am in motion. Look at this pic. Here you can see in this picture, some people are taking rest. So you can see a man lying on the bed, a old woman sitting on the chair, and the girl is sitting on the floor. On the other part of the picture, you can see a man running, a boy cycling. So some are at rest and some are in motion. What is this rest and motion? Suppose that you are traveling in a bus. When you look through the window, what do you observe? You see all the buildings, trees, people, vehicles, they will be passing by and you feel that you are at rest. And what about the person who is on the road? He also feels the same, that you are moving along with the bus. Who is right? Think over it. Okay. Now children, are the walls of your room moving? Can you feel the movement? You know that Earth is revolving around the sun. As such, why don't we perceive the motion of the Earth directly? To know the answers to these questions, let us move on to our today's topic, motion and time. When do you say a body is in motion? When do you say a body is in motion? When it changes. When the body changes its position with respect to time and observer. When is the body at rest? The body is at rest when it does not change its position with respect to time. So we say that a body is in motion if it changes its position with respect to time. It is at rest when it does not change its position with respect to time. Coming to our questions. When you look through the window, you see everything is passing by. You are right. Even the person who is outside, who is standing on the road, he is also right, because this rest and motion, it depends upon the observer and its surroundings. Without the observer, there is no meaning to the words rest and motion. And are the walls of your room moving? With respect to Earth, they are not moving. But when we take the reference of the sun, you know that Earth is a planet revolving around the sun. When Earth is moving, we should also move. So walls are moving. So this rest and motion, it depends upon the observer only. Without observer, there is no meaning to rest and motion. Okay. Then why don't we feel the motion of the Earth? Why don't we perceive the motion of the Earth directly? Because we will also be moving along with the Earth with the same speed as that of the Earth. Let us now try to scientifically define rest and motion. What is the scientific meaning of motion and rest? Motion is a combined property of an object under the observation and the observer. Everything in this world is at rest or in motion. There is no meaning of rest and motion without the observer. There are three types of motion. How many types of motions? There are three types of motions. One is the translatory motion. Second one is the rotatory motion. And third one is oscillatory motion. This is the straight line motion. Translatory motion is a straight line motion. Rotatory motion is a motion of an object in circular path. It is called as a rotatory motion. And oscillatory motion is to and fro motion of a body. Here translatory motion is a straight line motion. When a body moves in a straight line, we say that the body is in translatory motion. Now rotatory motion, it is the motion of the particles in a circular path with respect to a center or axis of rotation, and oscillatory motion is to and fro motion. Now let us look at the examples for these motions. Here you can see the vehicles moving on the road. They are the vehicles moving on the road. They are in translatory motion. A man is throwing the ball. The ball is moving in a straight line. And also when fruits fall from the tree, they too follow the translatory motion. And the second one is rotatory motion. Here you can see the blades of a windmill fan, they rotate about an axis. This is an example of rotatory motion. And motion of a top, it is also an example. Then coming to vibratory motion or oscillatory motion, the motion of the strings of musical instruments, the swing, the girl moves forward and backward. Forward and backward motion or upward and downward motion is called as oscillation. The minute differences in between all these motions you will come to know in your higher classes. Okay, let me show you the types of motion. Here, a car is moving. A car is moving. This car is in translatory motion. Now children, you can see two types of motions here. One is a translatory motion, another one is a rotatory motion. Here the tires of the car are rotating. So two types of motion you can see. And now, here this is spinner. This motion is called as rotatory motion. This is an example for rotatory motion. This is an example of rotatory motion. And this is a model of pendulum. When you take this to a side and leave, it starts making forward and backward motion. These are called as oscillations. The to and fro motion of a body is called as oscillation. You can see the oscillations. And with this only, I can show you the circular motion also. So this is the circular motion. This is the circular motion. Okay. Now let me show you the vibratory motion. So this is the hacksaw blade. These are the vibrations, the to and fro motion of a body. These are the vibrations. This is an example of vibratory motion. Now next, how do you measure time? You know, we use clocks. We use clocks to measure the time. We use, look at the picture. There is analog clock and a digital clock. Using these we can measure the time. The basic unit of time is second. In olden days, when these clocks were not invented, people used to measure the time using the sand clocks, water clocks and sundial. Let me show you an example of model of sand clock. This is the model of sand clock. This is the model of sand clock. Okay. Now, let us switch on to our next topic with a small experience which every parent will face at the house. Now, here is a situation of a boy and a father. The father orders the boy to sit at one place and read till my return. I have some work, I will go out and come within few minutes. So, saying this, the father leaves to work. This boy, children are fully energetic and they are fond of playing games. What this boy does, he'll go here and there, he'll play, he'll go into the kitchen, he'll go that side, this side. By the time the father reaches home, he will be in the same position. The father finds him in the same position and feels very happy. He thinks that my son is very obedient, but this is not the case. Okay? Now, how do we relate this situation to our next topic? Here, we are trying to explain distance and displacement. Distance is the length of the path covered. Coming to this boy, the boy makes random motions. So, the length of the path covered is called as a distance. Okay? Now, next, displacement. This is the initial position of the boy, and after moving here and there, again he came and sat in the same position. So, there is no change in the initial and final positions. So, displacement is 0. So, we say that distance is greater than or equal to displacement. Displacement is nothing but straight line motion, length of the path in a particular direction. So, here the displacement is 0, but distance can never be 0. When is distance equal to displacement? Suppose this is the shortest path between 2 points A and B. If the object moves in this path only, then distance is equal to displacement. We denote distance by the letter S and displacement by the letter S with arrow mark on it. What does this indicate? This indicates that distance is a scalar quantity to describe which only the magnitude is enough, and displacement, to describe it we need both the magnitude and the direction. Here we need to specify the direction. It is nothing but distance in a particular direction. Now, look at the picture here. Distance is the total length of the path covered and displacement is the shortest length between the 2 points. Now, children, there are 3 paths to move from A to B. One is the straight line path and the 2 are the curved paths. Which path is the shortest one here? A straight line path is the shortest one. So, we call it as a displacement, and the length of the 2 paths, curved paths, we call them as distance. Okay? And the SI unit of this distance is meter, and that of displacement is also meter. Distance and displacement both are measured in meters. Okay? Next, speed. Look at the picture. Speed is the distance travelled by an object. Speed is equals to distance by time. It is a scalar quantity. Its SI unit is meter per second. On the other hand, velocity is the distance travelled by the object per unit time in a particular direction. Velocity is equal to displacement by time. This velocity is a vector quantity. The SI unit of this velocity is also meter per second. Here, when a body travels in a straight line in a particular direction, we say that it possesses velocity. If it travels in a curved path, then we say that body has a speed. Now, look at the next pic. Here there are 2 points A and B. A cyclist has to choose two ways. One is the curved path, another one is the shortest path, that is a straight line path. Here when we say that, suppose the speed of his cycle is 1 kilometer in 1 minute, suppose. So, he is moving with a speed of 1 kilometer per minute is the speed. To say that he has velocity, we have to say he is moving with a speed of 1 kilometer per minute due east. due west, any direction. You need to specify the direction. So, velocity is speed plus direction. It is a velocity. Okay. And in front of the vehicles, we see a speedometer is fixed. In every vehicle, you can see this speedometer. Speedometer is a gauge that measures and displays instantaneous speed of the vehicle. Instantaneous speed in the sense, speed of the vehicle at a particular point of time. And when we raise the accelerator or lower the accelerator, the speed changes. Next, odometer, the digital reading. At the center you can see it is the odometer. Odometer is a device which is used to record the distance covered by that vehicle. Okay. Next, uniform motion. When do you say a body is in uniform motion? If a body covers equal distances in equal intervals of time, we say that the body is in uniform motion. For example, to reach from point A to point B, so it takes 1 minute time, 1 minute and 1 minute. If it covers 1 kilometer, 1 kilometer, 1 kilometer, then the time interval is same and the distance covered is also same. Then we say that that body is in uniform motion. Non-uniform motion. If the body does not cover equal distances in equal intervals of time. Suppose a vehicle is moving, let us take the same example, 1 kilometer in 1 minute, 2 kilometers, then 1 kilometer. Here the distance covered is not same. Then we say that the body is moving with non-uniform motion. Now let us study this uniform and non-uniform motion in the form of a graph, graphical representation of the motion. Look at this picture. This is a graph of two friends, Divya and Monica, who are studying in the same class. After the school, they are leaving for their homes, which lie on the either side of the school. Now let us first study the motion of Divya. You can see in 1 minute, here to draw the distance time graph, we have to take time on x-axis and distance on y-axis, and appropriate scale you have to write. Here the scale is on x-axis 1 centimeter is equal to 1 minute, and on y-axis 1 centimeter is equal to 100 meters. Now Divya in 1 minute she covered 100 meters. In 2 minutes she covered 200 meters. 3 minutes 300 meters. Likewise, she reached her home in 12 minutes covering 1200 meters. Here the time interval is equal and the distance covered is also equal. Okay. So we say that Divya is moving with uniform motion and the graph of her motion is a straight line passing through the origin. Now let us study the motion of journey of Monica. Journey of Monica. Monica in 1 minute she covered 200 meters. In 2 minutes she covered 400 meters. In 3 minutes 600 meters. In 4 minutes she covered 800 meters. Thereafter she took rest. She sat for 6 minutes After sitting for 6 minutes, again she started her journey. In the 11th minute, she covered 1000 meters, and in the 12th minute, again 1200 meters. This is her journey. She did not cover equal distances in equal intervals of time. So, we say that her motion is a non-uniform motion. For the non-uniform motion, you will not get a graph which is a straight line. It could be a curve or a graph of any shape. The rest period here is shown as a line segment parallel to x-axis. So, Monica's motion is non-uniform motion, Divya's motion is a uniform motion. Now, let us calculate the average speed of both Divya and Monica. How do you calculate average speed? Average speed is equal to total distance covered by total time taken. Total distance covered by total time taken. What is the total distance covered by Divya? It is 1200 meters. It is 1200 meters. How much time she took? She took 12 minutes. So, her average speed is 100 meters per minute. Now, let us calculate the average speed of Monica. Monica also covered 1200 meters in 12 minutes. Her average speed is also 100 meters per minute. The use of this distance time graph is that we can find the slope. How do you find the slope? Slope is equal to y2 minus y1 by x2 minus x1, that is nothing but distance by time. What is this distance by time called? It is the speed. So, this graph is used to find the instantaneous speed of the object. Now, let us find the speed of Divya and Monica in 4th minute of their journey. So, in Divya's speed, instantaneous speed in 4th minute, she covered 400 meters. 400 meters in 4 minutes. So, her journey is 100 meter per minute. Okay. Now, Monica's instantaneous speed in 4th minute. After 4 minutes, she covered 800 meters. 800 meters in 4 minutes, that is equals to 200 meter per minute. Okay. So, this is the slope of Divya and Monica. It is instantaneous speed. It changes from time to time. The slope of the Monica for the period of rest is 0. Okay. So, like this, using the distance time graph, we can find the instantaneous speed of the body. Okay. Let us move on to our next topic, that is acceleration. Acceleration is nothing but it is a rate of change of velocity. Acceleration is denoted by the letter A. It is equal to velocity by time, that is v bar by t. Its SI unit is meter per second, by second is meter per second square of acceleration. When do you say that body is in acceleration? When its speed increases, we say that body is in acceleration. When its speed decreases, we say that it is in deceleration. For example, a train approaching the station, slowly its speed decreases. When it reaches the platform, it will become 0. So, we say that the train is moving with deceleration. Okay? Now, a train leaving the station, slowly its speed increases from 0 to maximum, then we say that it is moving with acceleration. Now, when a body is moving in a straight line, suppose its speed is 30 km per hour. after reaching the destination also 30 km/h, then we say that this body does not possess any acceleration because it is moving with a constant speed. Now when it takes a linear curvilinear motion, here after reaching here also its speed velocity is 30 km/h, then now there is a change in acceleration because though the speed is constant, its direction changes. That is why we say that this body possesses acceleration. How do you find the acceleration? Suppose that is a point A and B. A body is there whose initial velocity is denoted by the letter U. It is 0 meter per second. After that time t is equals to 5 seconds, it reaches here. Its final velocity v is equals to 10 meter per second. What is this acceleration? Acceleration A is equals to v minus u by t, that is 10 minus 0 by 5 is equals to 2 meter per second square. It's acceleration. Okay. Now the relationship between initial velocity, final velocity, acceleration, displacement and time is given in the form of equations. We call those equations as equations of motion. First equation of motion is v is equals to u plus at. Second equation of motion is s is equals to ut plus half at square. And third equation of motion is v square minus u square is equals to 2as. How do you get the first equation? We get the first equation from acceleration formula. A is equals to v minus u by t implies v is equals to u plus at. And second equation of motion from average velocity, v plus u by 2 is equals to s by t. Here substituting v is equals to ut in this equation, we get u plus at by 2 is equals to s by t. This implies that 2u plus at into t by 2 is equals to s. S is equals to 2 ut by 2 plus at square by 2, cancelling 2 and 2, you will get ut plus half at square. So this is the second equation of motion. Now we can also derive the third equation of motion again from average velocity formula, s by t. A is equals to v minus u by t, t is equals to v minus u by a. So v plus u by 2 is equals to s by v minus u by a. We can write v plus u into v minus u is equals to 2as. This is in the form of the identity a plus b into a minus b, which is nothing but a square minus b square. So v square minus u square is equals to 2as. This is the third equation of motion. So children, today what we have learnt? We have learned that motion is relative. There are three types of motion. Speed is a scalar, velocity is a vector, time distance graph of a uniform motion is a straight line passing through the origin, and that of a non-uniform motion is not a straight line, rather it is a curve or a graph of any shape. Next, slope of the time distance graph line is a instantaneous, it shows the instantaneous speed of the body. Then acceleration is the rate of change of velocity. And last one is the equations of motion. We have three equations of motion. V is equals to u plus at. Second one, s is equals to ut plus half at square. And the third equation of motion is v square minus u square is equal to 2as. Okay. Next, children, project, you do this project. Illustrate the race between the rabbit and the tortoise in the form of a graph and derive the equations of motion. That's all for today.